Well, hello geometry students. We've made it. We've made it to our last notes on our triangle foldable. Hope you guys are excited. I certainly am. All right, today's notes are titled 9-8, and our title, we'll get to in a minute, we'll write it down, but it is angles of elevation and angles of depression. To illustrate this on the front of our foldable, let's draw a picture. Let's draw yourself. All right. And our self is located on a plain, and we see, in a prairie, and we see a hot air balloon floating in the sky. All right? And we can see that hot air balloon. There's kind of a line of sight from us to the balloon. And we can talk about angles of elevation and angles of depression from here. From a horizontal line, so if I draw a horizontal line, I'll label that. From a horizontal line going up to my line of sight is called the angle of elevation. Okay, so going up from a horizontal line is angle of elevation. Angle of depression then is going to go down, and that horizontal line has to, we still have to have a horizontal line. So a horizontal line from the top, from the hot air balloon, a horizontal line going down then is an angle of depression. So we'll label that. Okay, so let's look at that and understand what we're seeing here. From any horizontal line going up is an angle of elevation, and a horizontal line going down is an angle of depression. Very important we see that. A couple things that we can make a triangle out of this then. From any image we see angle of elevation, it makes a right angle, okay? And our angle of elevation will fall inside of our triangle. Quite simple. Our angle of depression, rather, is outside of the triangle. So there's some things we have to do to get our angle inside the triangle and find whatever it's asking for. All right? Let's open up our foldable, and I already have this written down for us. I would like for you to pause this video and copy down our problem. It says an eagle is flying at an altitude of 150 meters. He spots his prey at a 33-degree angle of depression. What is the eagle's horizontal distance to the prey? Okay, make sure you have that copy down. Next, we're going to draw a diagram. All right? Always got to draw a diagram in geometry. So let's draw the eagle. He's flying, and he sees his prey down here. He's scurrying across the ground. Okay? Now, from an angle of depression is the way he sees it. So from a horizontal line, I'm going to dot this. Here's my horizontal line going down to the prey is 33 degrees. Okay? We can draw out the rest of this then. He's flying 150 meters, his altitude, he's flying that high. So I can label that 150 meters. And it wants to know his horizontal distance to the prey, so from there, going straight over to the prey is how far I want to see. How far is that? Okay? Now, I'm going to use trigonometry for this. I have one side, I need to find this side. I don't have any angles inside of my triangle, but I can quite easily find that. Since my angle of depression is 33 degrees, the angle right inside the triangle here will be its complement, which means I add up to 90. So if we take 90 minus the 33, that leaves us with 57 degrees is our angle inside the triangle. All right? Then I can take a look at this triangle. From that 57 degrees then, I have my opposite side x, I have my adjacent side 150, and the trig function that uses my opposite and adjacent, you should know this by now, is tangent. We could take a look at SOHCAHTOA and find that. But my tangent of 57 degrees is equal to opposite over adjacent, x over 150. Okay, put tangent 57 over 1 and cross multiply. So I've got 1 times x is x, and 150 times the tangent of 57. All right, plug that in my calculator, and I'm going to get a value of 230.9797. So let's round that to the nearest whole unit, is 231 meters as a horizontal distance from the eagle to the prey. Now, if I found 57 degrees there, I could also see that my angle down here will be 33 degrees in a triangle. So I could have used 33 degrees to find the exact same thing, but my proportion would have been set up a little bit different. Notice that 33 degrees was the same thing as my angle of depression, because those are alternate interior angles, okay? And the 33 degrees that would be down here, I'll label it now, this would be classified as an angle of elevation. We could also say that from the prey up to the bird, the eagle, is an angle of elevation of 33 degrees. The angle of depression is a little harder to see sometimes. That's why I wanted to give you an example of that. But we can use angle of elevation, and angle of depression the same way with our trigonometry to be able to find distances needed. Okay? Don't forget your WSQ. Bring these notes to class. Have a great rest of your day.